This is an engine powered simply from the heat of my hand. Today I'm talking to Roy Darlington, an engineer who knows all about these engines. Welcome, Roy. Can you explain how this works?
Yes, this is a low delta T engine.
Right.
The idea was invented by the Reverend Stirling
Yeah.
in the early 1800s. And this is a later development. There's quite a few of these about the world now. The Stirling cycle is a sealed system.
So inside this chamber here it's sealed?
It's totally sealed.
Yep.
There's no inlet, no exhaust
Yep.
to a Stirling engine.
I'm applying heat with my hand
Yeah.
to one side.
The bottom plate, this bottom plate, is the hot side.
Yep.
The top side is the cold side.
Yes.
The piston in there, the white piston, doesn't fit. There's a gap all around it,
Yes.
and the air is moving as that displaces air from the top to the bottom.
Yep.
When the air is on the hot side, the temperature makes the expansion
Yep.
inside this cylinder,
Which pushes the piston
and it
up.
pushes the piston up.
Yep.
When the air is on the cold plate,
Yes.
it contracts, and it sucks the piston back down, and that's it basically.
Yeah. And because you've got a flywheel here, it
That
keeps the
keeps
whole
it
thing
going.
going.
It's the little power piston there doing the work. Not round the other side there, Jonathan. That is moving the displacer.
Yeah.
So that piston is driving the displacer up and down.
It's absolutely magical thing. And you told me, I think this can work on, was it 1 degree difference in
1
temperature?
degree differential
Between the top
between
and
the
bottom.
bottom plate and the top plate.
So if you leave this out on a hot day, with the sun shining on the top,
It'll
and
go
that
the-
cold,
It'll go the reverse
It'll-
direction.
yeah,
It'll run in the sun.
isn't that wonderful? So obviously that is a wonderful demonstration, but it actually won't power heavy
If you
machinery.
If you don't put anything in, you don't get anything out.
But here we've got this beautiful model that you made here of this boat. So tell me a little bit about this. This is obviously a higher power version.
Yes, this is Sterling Silver 2. It's known in most countries in the world, but it's been all over Europe, all over England, in quite a few different lakes and ponds. The engine does 3,000 RPM, and it runs for 3.5 hours on a cylinder of gas.
That's amazing.
And it beats all the steamboats. So
Yeah.
that's the thing I enjoy most.
We're going to talk in a minute how this works, but of course the important thing is there's a difference in temperature, isn't it?
Yeah.
And I guess because this is on water, you've got a nice cold water surface
Yes.
at one constant temperature.
This is a water jacket there,
Yeah.
and it picks the water up from the propeller and pumps water, cold water, whatever the temperature of the lake is.
Yep.
That is the temperature of the cold side.
Yep.
So you get a big differential there.
Yeah. And then the hot side obviously has been heated by whatever you want.
Yes.
Whatever. Here you're using gas.
Yes, I'm using gas with a little regulator there, so that the size of the flame is always the same.
Now, the Stirling cycles we'll see in a minute is a closed system, so the only exhaust is just coming from your heat source, isn't it?
That's right.
The actual engine doesn't have
There's
any...
no exhaust.
No, it's completely closed. So we've got a little demonstration here. I wonder if you can talk me through this.
Yep. This is a displacer cylinder.
Okay, this is equivalent to the white one that went up and
Up
down
and
there.
down.
And one of those,
That's
yes.
right. And this is the power cylinder.
Okay,
This is with the little black cylinder on this one.
yeah.
That's that one there.
So this cylinder is connected to the thing that's going to do the
Yeah.
work.
This is an ordinary crank mechanism,
Yep,
as you would have in a steam engine.
yep, okay,
Just identical.
yep.
But this engine is actually driving this displacer.
Yes. Okay.
And when the air...
So Roy, just sorry. So we've got some air in this system, but
That's
it's
right.
completely closed from the
It's-
outside world.
It's a totally sealed system.
Yep.
There's no inlet, no exhaust, no valves.
Yeah. And as the pressure changes on here, we'll see in a
Yeah.
minute, it does...
As
the
it's a
action
sealed
work.
system,
Yep.
whatever the pressure is here,
Yep,
it is the same in this chamber there.
okay.
Now, when all the air... by the way, this displacer piston,
Yes.
there's a gap all the way around it, which allows the air to move over piston.
Which is why it's called the displacer, because it just
It
moves
displaces
the air
it
from one
to the other.
Yeah, okay.
And the Reverend Stirling invented this in 1816 because so many people were killed with boilers blowing up.
Yeah.
And it's the engine of the future,
Yeah.
as far as I'm concerned. And
So you've got a heater here that's producing heat.
that's just to demonstrate
Yep.
that end is
It's hot.
heated with a burner.
Yep.
And
So I can move this mechanism.
yeah,
Yes.
if you turn it over
Okay.
slowly,
Yes.
this piston is always in advance, 90 degrees in advance of that one,
Yep.
which gives the timing.
Yes.
Now, this piston has moved to the hot end.
Yep.
The air has gone over this piston
Yes.
to the cold end.
Yes.
When it gets in the cold end, the pressure drops,
Yep.
and that helps to suck
Yep.
the piston up,
That makes it go up.
aided by atmospheric pressure
Yep. Yep.
under the piston.
Yes.
Now this piston is moving back, the air's coming to the hot side,
Yes.
which pushes the piston,
Expands the air and pushes the piston back down,
again.
And as long as you've got a flywheel, that whole process just keeps on
Just
going.
keep going.
And the thing just turns.
Yeah. This one does
Fantastic.
3,000 RPM.
Wow. That's absolutely amazing. So, I mean, it is amazing that you've got this closed system, so you've got no exhausts or anything. You were telling me about them used in submarines.
Yes. In Sweden, they power 6 submarines with Stirling engines. And the very latest submarine has got 3 Stirling engines in it. And one of those engines is a direct drive to the prop.
Yep.
The others supply all the heating,
Yep.
all the electricity for the electronics.
Yeah.
And in the very first instance, they just put one engine
Yep.
in a submarine, and they won't tell you how long it can stay down, but it did add 24 days to the underwater duration.
That's amazing. So you can't necessarily apply this to everywhere. You were telling me earlier that it's not always the best thing for cars, is it?
No, the problem with a car is that when you're driving your car,
Yeah.
you throw 24% of the heat straight out the exhaust at the back. If you're running a Stirling engine, Stirling runs best at a constant speed.
Right.
So if you came to the lights,
Yep.
you would overheat.
You'd heat up the engine. There wouldn't be the change in temperature anymore.
To get over that, you'd need a radiator
Yes.
in a car
Yep.
the size of a lorry.
Right.
And as a radiator is a very expensive item,
Yep.
no car manufacturer wants to put a bigger one, and of course all the streamlining would go as well.
Yeah. Yeah.
So for a car,
Yep.
and the only way to use it in the car
Mm.
is to have a small engine driving a generator, power the wheels with electric motors,
Yep.
and charge the batteries.
Yeah. Fantastic. So the Stirling engine and the heat engines are magnificent, but actually you go back a long way with engineering, don't you?
Yes, I do.
So what started you off?
Well, I've always been interested in model engineering. At the age of 10, I was playing about with the batteries, and I used to make model boats.
Yep.
And to power them, we didn't always have the pennies for the batteries.
Yeah.
So my early model engineering started making water turbines
Right.
to run off the tap.
Yeah.
And I had a little electric motor that was used as a generator.
Make electricity.
So water turbines was the first thing I made.
And you worked in Spitfires in the war?
Yes, I left school at 15, and I was an apprentice joiner.
Mm-hmm.
I then was on Shoreham Beach
Yes.
as a aircraft spotter. Excuse me. And as soon as I was in the Air Defence Cadet Corps
Yep.
for 3 years, and I was training to be a flight engineer. When I got in the RAF, they found I was colourblind, so I turned out to be a mechanic,
Right.
an engine fitter.
That was probably
And
good luck in some
The
ways.
first squadron I was on was at Biggin Hill
Yes.
on 611 Spitfire Squadron with the air aces Milan, Al Deer, Squadron Leader Charles, who, if anybody reads books on the Battle of Britain,
They're famous names.
they're all famous names.
Yeah.
And I was very proud to find myself on that squadron.
And were you fixing the engines?
Yeah,
or
and
developing?
fitting drop tanks and generally doing the daily inspection
Yeah.
and filling them up with oil, petrol and coolant.
And you told me that there's a Lancaster bomber still in use.
Yes,
And
there was. Later on I switched to Stirling bombers. I spent 2.5 years on a Stirling. That was larger than the Lancaster.
yeah.
And eventually wound up in West Africa on Lancasters. And the Lancaster that still fly was my aircraft, one of 6 brand new Lancasters that we had in Africa.
Yes.
Yeah.
Roy, thank you very much. It's been really fascinating. I know you've got a book out, and the details of that are going to be at the end of the little film here. But thank you very much for talking to me.
My pleasure.